Hello, everyone. My name is Andy Simon, and I am a Product Marketing Manager for Sun Nuclear Corporation. I'd like to welcome you to today's presentation, brought to you by Sun Nuclear in partnership with AAPM and the International Journal of Medical Physics. It is my pleasure to introduce today's speaker, Dr. Cassandra Stambaugh, a medical physicist and assistant professor at Tufts Medical Center, where she has been since July of 2017. She received her doctorate in physics from the University of South Florida Moffitt Cancer Center and completed her residency at the Mayo Clinic School of Health Sciences in Phoenix, Arizona. Dr. Stambaugh's research focuses on patient-specific quality assurance as well as patient safety and clinical efficiency. I'd like to thank Dr. Stambaugh for being with us today and giving this presentation, Comparison of Vendor-Dependent versus Commercially Available Independent Linac Quality Assurance.
Hello, everyone. I am Cassandra Stambaugh. Today I will be giving an overview of a quality assurance test platform provided by a Linac vendor compared to a commercially available independent platform. We'll start with a review of the two platforms we will be discussing. We will then go through a direct comparison of features and tests available with each platform, as well as the efficiency, and then finish with a snapshot of QA result comparisons. So we'll start with why are we even looking at this comparison? The increase in complexity, personalized treatment plans, and techniques in radiation oncology clinics increases the demand on quality assurance as a whole. With so many needs to address, it is not surprising that physicists yearn for ways to simplify processes and increase efficiency. When vendors supply built-in QA options for their equipment, naturally, the question becomes how those tests could be used to help either reduce QA burden on the staff, increase safety, or increase efficiency of QA tests. The question of whether these built-in tests can be used to replace other daily QA is frequently asked. So when our clinic was looking at setting up our daily QA program on our new Linac, we wanted to assess how best to utilize these supplied tests. The biggest argument against using these vendor-supplied system tests as a replacement is that they are generally not designed for routine QA. They are not an independent QA system, but instead are designed as troubleshooting tools for physicists and service engineers for the vendor. This often means that the tolerances for machine performance from the vendor point of view may be different than recommended tolerances or the tolerances that the clinic may want to assess. Therefore, these provided tests are not a replacement of an independent QA platform. However, the perceived efficiency and the recommendation that these tests be performed daily anyway can make using these tests as a replacement very tempting. The systems also generally come with their own phantoms, automatically analyze results, trend data, and do have tests that overlap with daily QA recommended tests. Compare that to the need to purchase potentially multiple phantoms for use with an independent system, and the vendor-supplied tests look pretty good. That being said, the efficiency of these built-in tests haven't been evaluated in comparison to an independent, fully comprehensive QA system. So while the assumption is that they are more efficient, it remains to be evaluated. Based on these potential benefits and drawbacks, the aim of our original project was to evaluate both the vendor-supplied built-in QA as well as an independent QA platform in terms of efficiency, appropriateness for the task, overall data collected, as well as agreement of results for daily QA. We recently installed a new Linac in our clinic. This was a major infrastructure shift and included the purchase of a new QA platform and the introduction of a fair number of new daily QA tests, including a fully compliant TG-142. Full implementation of the new QA procedure and training was provided to 3 of our radiation therapists. They rotated daily QA responsibilities. Besides the requirement to perform the necessary QA tests, there was no restriction on what order the tests needed to be performed or a requirement for the QA to be performed in one sitting. After 4 months of use with this new process, 3 months of daily QA data was collected and analyzed. All efficiency data was collected based on timestamps from the two platforms and confirmed when needed through our record and verify system. With our infrastructure change, we switched to a SunNuclear QA platform, which included SunCHECK machine with the daily QA3 Phantom for daily QA. Additionally, we now had machine performance check available on our TrueBeam. Due to the number of new tests, the new system, and the addition of machine performance check, our radiation therapists were initially very concerned about how much extra time daily QA was going to take in order to be ready to treat for the day. As a compromise, we set up a procedure that split the machine performance check tests so that each day 5 of the 10 tests pertinent to our clinic were performed and the tests were alternating days. We will go over in more detail how that can be set up later. The data collected from both machine performance check and SunCHECK machine was analyzed in Excel. The time needed for the overall daily QA was assessed, as was the time for machine performance check and SunCHECK machine separately. We further analyzed the SunCHECK machine data for time spent on dosimetry and time spent on everything else, since, as we will discuss later, the dosimetry tests have a larger automation aspect and therefore are less susceptible to user variation. Output for a photon, electron, and flattening filter-free beam were collected, as was center shift data for the photon beam. The results from each platform were compared to assess how consistent results were between the two. We also assessed total daily QA time per radiation therapist to assess if there was any variation which may point to a bias due to a training issue. In addition to looking at efficiency of the different platforms, we also assessed them on features and relevance to daily QA. We used TG-142 as base reference for our comparisons of relevance. As a reminder, TG-142 recommends for daily QA dosimetry, mechanical, and safety checks, as well as imaging and, in our case, EDW checks. Since MLC tests are recommended weekly, this work did not explicitly compare the platforms on this test. Additionally, our Linac has other systems such as surface guidance that we did not compare on. Since each clinic will vary on what systems they use, we address these additional tests in terms of customizability of the platforms. So let's take a deeper dive on these platforms. SunCHECK is a server-based web application which is accessible from any networked PC. While there are many functionalities within SunCHECK, we will be focusing this talk on SunCHECK machine, which assists in the QA of treatment delivery systems, including linear accelerators. The system can be utilized for all QA, including daily, monthly, and annual QA on the Linac. For comparison's sake to machine performance check, this talk will focus on the daily QA functionality. In our clinic, SunCHECK machine integrates with the daily QA3 Phantom from SunNuclear for consistency checks of various beam parameters. When initialized, the data is automatically collected, analyzed, and saved. Immediate feedback is provided to the radiation therapist on the results of the test. Here you can see an example of a set of dosimetry results using the daily QA3. All parameters with the same energy are collected with one beam measurement and compared against a baseline measurement. Results are automatically displayed with both visual color cues, measurement values, and tolerance displays. With SunCHECK machine, there are pre-built templates that can be utilized based on your machine type that comply with TG-142. These can be used as is, or you can customize the template based on your clinic's needs. Here is an example of a pre-built check set that we customized for our clinic. As you can see in the custom results section, you can choose what type of check you want, set expected values, or make checks pass-fail. You can also build completely new tests with similar customization. Due to the customizability of the platform, the full daily QA can be captured in one place. Tests can also be ordered in a way that makes sense for your clinic, so efficiency based on setup can be maximized. Trending of data can be accessed in various fashions, but while in the results window, any check that has a measurement value associated with it can be trended by clicking the graph icon next to the parameter name. Trending can be viewed on various zoom levels. Comments can be seen on the trend line if available, and clicking on any data point brings you back to that day's results. If you expand the machine, then all checks are available to trend as well. The trended data can be exported as a group, or the individual day's data can be exported so that further analysis can be performed if needed. Since SunCHECK is a web-based platform, you can access that data from any networked computer. This makes reviewing daily QA very easy to do since you can do it right at your workstation. You can also set up your account to get email notifications if a QA set fails so that you can very quickly assess clinical issues. Other functionality of the platforms include the ability to schedule when tests should occur. The login page of the platform displays any tests that are due, so it is very easy for the radiation therapist to access. They also have the ability to add comments on tests, and rights can be adjusted so that only certain groups can reopen and approve QA sets. Reports can also be generated as needed. Machine Performance Check, on the other hand, is an integrated self-check tool used to verify if the critical functions of the system are operating within specifications. The application is designed for reliable and fast system testing on a daily basis before routine treatment starts. Performing Machine Performance Check beam and geometry checks requires the IsoCal Phantom, seen here, to be mounted to the couch. After imager calibration, baselines are captured with IsoCal Phantom at a specific couch reference. Once this is done, Machine Performance Check automatically drives the Phantom to the correct position and then automatically acquires a series of MV and KV images per energy, capturing beam properties as well as mechanical characteristics for different collimator and gantry rotations, couch settings, and collimating devices. The acquired series of images is immediately processed and the results displayed to the user for quick evaluation. Here you can see the results on the left. The results indicate whether the values are within system specifications using green, yellow, and red color cues. If a set of tests are repeated in a given day, as seen here, the original results are kept and then repeated set is shown next to it. This is an option you can toggle on and off, as is seen empty days and limiting the view to 90 days. You can click on each set of results, which opens a more detailed window of what was included in that check as well as the result. This can be seen on the right. The acquired images also are available for further analysis if needed, and similar imaging tools that you would find on the TrueBeam console are available. From the detail view, you can hover over the individual tests to enable the display of the trend icon. If that is clicked, then you enter the trends view. From here, you can add other trend items, zoom in on certain areas of the trend line, and enable the point values so you can read off results from the trend line. While very beneficial, it is not intuitive to enter this workspace. It honestly feels like you need to know where the secret door is. Nor is it very apparent how to add trend lines or work with the trend lines. However, you can export the data and work with it in a separate software, which is very nice. You also have the option to set up Machine Performance Check on a separate workstation so you can access it in an offline mode. This simply means you can access the software and data from a separate workstation when the machine is being utilized. You do need a license for this feature. You can also print reports from the console and set a schedule of tests. This allows the therapist to simply run the tests scheduled instead of needing to remember which runs to run and when. Also, if the test was skipped but scheduled the day previously, then it will continue to appear until it is run. Now that we have a general idea about how these platforms operate, we can do a little head-to-head comparison on basic features. We'll start with ease of use. Both platforms overall are very easy to use. Besides taking initial baselines for a machine performance check, it is fairly plug and play. SunCHECK Machine has pre-built templates for daily QA in compliance with TG-142. So from that regard, it is easy to set up a template. Where it drops in ease is the number of baselines needed and if you choose to customize the template. While not especially difficult, it does take more time and some iteration to get the template to where you would like it to be. This also plays into the automation side. For both platforms, you need to initiate each energy, but for machine performance check, that's about it. For SunCHECK Machine, the more custom tests you have, the more human interaction is needed. The dosimetry checks are very nice and you get a lot of data with one beam initialization, but there is a lot of typing in the results for the rest of the tests. The phantoms for both platforms are very easy to set up and use. We did find that we had more need on the MPC side to repeat tests due to results not capturing. SunCHECK Machine auto-saves, so the only issue we've experienced on that front has been user error. For the imaging test for SunCHECK Machine, the quasar pentaguide phantom is also utilized, and cones are utilized for the electron dosimetry checks, while for machine performance check, they are not. Therefore, more trips into the room are required for completion of the daily QA for SunCHECK Machine. Next is customizability. Both platforms really are nice in the ability to schedule tests. For both, individual tests can be scheduled according to the day of the week. The only nuance that we didn't originally appreciate is that the radiation therapist account settings in SunCHECK Machine doesn't show tests as available if they aren't scheduled. Therefore, we modified our scheduling so that the full QA was available on Saturdays and Sundays in case of emergency treatments. Both platforms will propagate tests until completed, so if tests are performed on the weekend, the QA is simply available on Monday. Beyond scheduling, however, customizability is where SunCHECK Machine really stands apart from Machine Performance Check in terms of features. SunCHECK Machine is completely customizable to fit whatever your clinic's needs are in terms of daily QA, and also allows for threshold adjustment if you want to have different thresholds than what TG-142 recommends. This might happen if you have a desire to have tighter tolerances. Machine Performance Check does have thresholds, but they are not changeable, nor are any of the tests. What you see is what you get. Another area that we found SunCHECK Machine to stand apart in is the accessibility realm. Machine Performance Check is easy for the radiation therapists to access since they are already on the Linac console. But there are no notifications of failed tests. While nice to have, the offline mode of Machine Performance Check is more difficult to access for physicists, and reviewing the individual test group results requires a lot of clicks. Also, there is no approval option to mark tests reviewed. SunCHECK Machine, on the other hand, does require a login to a web application, so an additional step for the radiation therapist, but does provide notification if desired. The platform shows all of the results on a single page and has a very easy approval process. The cherry on top is that since it is a web application, any networked computer can access the software. This means that even if you aren't on site, if you have remote access to your workstation, you have access to SunCHECK Machine. This, with the notification of failed tests, has been extremely beneficial with the need to be in the clinic less this year due to the pandemic. Finally, on the discussion of features, we look at trending and data management. As mentioned earlier, while both platforms have trending capabilities, the trending in Machine Performance Check is not very user-friendly. The multiple trending options in SunCHECK Machine gives the user a lot of flexibility in accessing the data. The ability to see comments on the trend line is very beneficial, so that notes on outliers can be easily accessed without a lot of investigation work. SunCHECK Machine also has multiple export options, so you can export a single test or a whole trend line. Machine Performance Check will batch export, and you need to go through multiple folders to access the correct test. That being said, the organization of the data for Machine Performance Check export is slightly better than SunCHECK Machine. Next up, we looked at TG-142 test satisfaction per platform. Machine Performance Check does report on beam output constancy, but since it is not designed as a platform for daily QA, it does not collect data on any of the mechanical or safety tests, and while some of these checks could be assessed while MPC is being performed, there isn't any way to record results of these tests on the Machine Performance Check platform. SunCHECK Machine, however, does. The dosimetry tests are automated with the daily QA3, while the rest of the test results can be manually entered into the system. For the remaining TG-142 tests, Machine Performance Check reports on the positioning of the imaging unit as well as the imaging and treatment isocenter coincidence for all imaging modalities. However, it does not look at repositioning or collision interlocks. It also does not assess the EDW. SunCHECK Machine does allow for data collection for these tests. They are part of the TG-142 template, but the results do need to be entered manually. While we use TG-142 as a base reference of comparison, it wouldn't be fair to not mention the other tests that these platforms do collect as part of the daily QA. Machine Performance Check performs many geometry tests and collects beam uniformity and center shift data. For our clinic, this translates to a total of 20 dosimetry checks and 15 geometry checks. Since we do choose to alternate the energy checks per day, of those 20 dosimetry tests, we perform 10 each day. However, the geometry checks are performed daily. On the SunCHECK Machine side, due to the integration with the daily QA3, when the beams are run to collect the data for the output constancy check, you also get flatness and symmetry, energy constancy, as well as field size and shift. Both platforms have MLC tests, but they are very different. SunCHECK Machine is a qualitative check where the radiation therapists are simply ensuring that the MLC moves through a picket fence test visually. Machine Performance Check, on the other hand, assesses the accuracy and the reproducibility of just the inner MLC leaves. As we've previously discussed, SunCHECK Machine also allows for a lot of customization to add any clinic-specific checks. So for our clinic, we've added certain checks for machine parameters like gas pressure and water level, as well as our daily QA for our surface guidance system. Our daily QA template has a total of 68 dosimetry checks in between safety, mechanical, imaging, and such, an additional 35 checks. Those all are performed every day. Therefore, we are collecting data on a total of 128 checks daily. 128 collected checks seems like a lot for daily QA, especially in comparison to the basic recommendations of TG-142, which would suggest 23. So let's now look at how long this actually takes. The total time spent for daily QA over the 3-month period we looked at averaged 32 minutes. Machine Performance Check averaged 11 minutes per day, and SunCHECK Machine averaged 21 minutes. Of the 21 minutes for SunCHECK Machine tests, on average 6 minutes was spent on dosimetry checks. The remainder was spent on imaging and mechanical safety checks. The time required to perform Machine Performance Check geometry and a subset of the dosimetry checks exceeded the time to perform all of the dosimetry checks for SunCHECK Machine. Machine Performance Check took approximately half the amount of time as a full daily QA using SunCHECK Machine, but performed significantly fewer tests. Overall, a half an hour for daily QA, especially for the number of checks performed, is very reasonable. It is on par with the time that had been spent on daily QA on our previous system. That system, however, did not meet the recommendations of TG-142, and fewer tests were performed. So overall, there was a noticeable improvement in efficiency with our new system. Our radiation therapists also noticed this and appreciated it. As was mentioned earlier, during this period, we did have some reliability issues with Machine Performance Check, and this is reflected in the standard deviation for Machine Performance Check being larger than SunCHECK Machine. The consistency we saw with the time to do the dosimetry checks with SunCHECK machine was quite impressive, and the variability of the overall QA time with SunCHECK machine is explainable with the fact there was a lot more human interaction needed with the non-dosimetry checks. The variability seen in time to perform the non-automated tests in SunCHECK machine had us wondering if it was a variability across all of our radiation therapists, an initial learning curve, or if there was a need for additional training for a subset of the group. As can be seen here, if we separate the overall QA time per radiation therapist and plot it in the order that they performed it, each radiation therapist had one instance where their QA time exceeded an hour, and otherwise there was similar variation amongst all three of them. The instance where the QA time exceeded an hour correlated with times that the machine performance check had to be performed multiple times in order for the results to properly record. For us, this ruled out a training issue or an initial break-in period, and more pointed to just normal daily variation. Since there was enough instances of breaks during the QA time, however, we did sum the time from the individual tests opposed to simply taking the time the QA was started and finished. This focused on the time that the QA was actually being performed and removed these breaks. While looking at the efficiency of the platforms is important, the collected results and how they compare to each other may be even more important. A fast test is worthless if it is giving inaccurate or inconsistent results. We picked one photon and one electron beam to compare output constancy, as well as our one flattening filter-free beam. Here you can see the results from our 6MV beam. The machine performance check results in blue and the SunCHECK machine results in orange track extremely well together, and they were found to not be statistically different from each other. The largest difference seen was 0.2% between the two platforms for the same day, well within the tolerance for daily QA. As a reminder, both platforms require baselines, and these are constancy checks of output, not absolute dose measurements. For electrons, machine performance check does not use a cone and looks at intensity of pixels from the EPID, while SunCHECK machine does use a cone, and the daily QA3 uses ion chambers for output constancy. Therefore, output constancy for electrons for these two platforms are fundamentally different on multiple levels. Even with that, the two platforms for 6MeV tracked well together and also did not show a significant difference. Since the 6MeV beam was run every other day for machine performance check, some large variations you can see recorded for SunCHECK machine were days that this energy was not run for machine performance check, and therefore we did not see the variation on that platform. The last energy we assessed for output constancy was 10 FFF. Once again, we did not see a statistically significant difference between the two platforms for this energy. This energy did demonstrate more of a difference between the two platforms initially, but the largest separation seen between the two was 0.7%. This was still well within the recommendations of TG-142. The flattened photon energy report center shift for machine performance check tests. So we also looked at this data for our 6MV beam. This is interesting because in theory, the EPID and phantom for machine performance check are set up identically every day due to the indexing of the phantom. On the other hand, the daily QA3 requires alignment with ISO, so is subject to setup errors. Also, since the daily QA3 is used for baselines in SunCHECK machine, if the device isn't perfectly centered for the baselines, then that shift influences all future measurements. Therefore, we looked at the machine performance check data compared to both the reported center shift values from SunCHECK machine, here in orange, as well as the center shift with the baseline shift removed, which you can see in gray. The center shift results for 6MV for both platforms agreed quite well for the first couple of months, but then showed a divergence in results in early December. This resulted in a statistically significant difference in results. While not a terribly large difference, since the two platforms are so consistent with other results, this discrepancy needs further investigation as to what caused this difference and which platforms is correctly performing the beam center shift reporting. After all of these comparisons, you may be asking, what are the main takeaways? Well, for our clinic, our takeaways were that we could assess many more parameters with SunCHECK machine than with machine performance check. And if we were to do all of the machine performance check tests, it would take approximately the same amount of time as a full daily QA with SunCHECK machine. Therefore, the efficiency of the vendor-supplied tests were not as good as we were expecting, and the independent QA system proved to be more efficient per test. Additionally, the tests available with SunCHECK machine are more applicable to compliance with the recommendations of TG-142, and the customization and features available aid in completing a thorough QA and review of completed QA. The fact that SunCHECK machine is an independent QA platform is definitely a major factor as well for our clinic. That being said, our clinic still utilizes machine performance check daily and will continue to do so. We see benefit in performing these tests, as if there is an issue with the Linac, the tolerances are set such that you know immediately that it is out of spec for the vendor and that you have a history of how those tests have been performing for your service engineers. As was seen, running the machine performance check tests in an alternating fashion does not add a significant amount of time to the total daily QA. So for our clinic, the benefit outweighs the cost. Now let's come back to our benefits and drawbacks list from the beginning of the talk. From our analysis of these platforms, we have seen that while machine performance check can be performed quickly and the results are consistent with an independent system for the most part, the efficiency comes with a lack of sufficient tests to fully comply with the recommendations of TG-142. This means that while machine performance check could theoretically perform a subset of the daily QA tests, a separate system would be needed to record results from the remaining tests as well as provide documentation of review and approvals. If you are going to have another system anyway, it is advantageous to have an efficient system that can handle the full daily QA, as a major drawback that still remains is that machine performance check is not an independent QA system. While it is excellent that these two platforms agree so well, having a machine test itself on accuracy is a difficult concept for many to accept, especially when it is recommended to have an independent system for QA. The argument of what constitutes independent QA is beyond the scope of this talk, but this should definitely be a consideration when utilizing any vendor-supplied tests. In conclusion, SunCHECK machine provides a more efficient, customizable, and applicable platform for daily QA compared to machine performance check when all of the recommended daily QA tests are considered. Machine performance check, on the other hand, is a great resource for troubleshooting. The agreement between the two platforms for output constancy is impressive, and if properly vetted against an independent QA system, would make for an excellent backup in case of hardware or software issues with your main QA platform. As with any study, this project did have limitations. Since we did this in a retrospective fashion, it did not have any restrictions on the daily QA process for our radiation therapists. We did see some variations simply based on the fact that the therapist didn't always do daily QA in one sitting. This required timestamp collection by test instead of overall QA. Also, a full set of machine performance check tests would ideally be run so that the trends could be compared on a daily basis. Finally, we would ideally have results from a separate system to measure center shift and the output results, so the differences such as what we see in the center shift data could be rectified. As such, we are currently working on a prospective study using a full machine performance check suite as well as guidelines for our radiation therapists in terms of order of tests and breaks. The physics team will also be running independent checks of output constancy and center shift on a weekly basis. Finally, the physics team will be running a set of daily QA with both platforms with errors introduced to assess when each system detects them. Thank you very much for your time. If you want any more future information, you can check these references out or contact me via email. And now we are ready for any questions.
Thank you, Dr. Stambaugh, for the wonderful webinar today. We really appreciate you taking the time. We appreciate everyone joining us. I do have a couple of questions that we'd like to go over now with respect to your presentation today. The first question is, considering practice changes forced upon sites based on the COVID pandemic, could you comment how these different tools integrate into the remote working environment?
Sure. So we've heavily utilized the SunCHECK machine platform while working remotely. You can set up accounts based off of preferences, and so I've set up mine so that I will get notified if any sort of QA, especially dailies, fail. So then I can remote into my computer, and from any browser I can log into the platform and check to see where the issues were and do approvals directly from home. We haven't utilized machine performance check as much from a remote standpoint. You can, but there are license restrictions, and so only a couple of people do the remote logging and checking what the daily results are.
Wonderful, thank you. I do want to encourage everyone on the line today, if you do have any questions, please go ahead and enter those questions, and we will go ahead and take those if we have some time here. Question number 2, can you give a little more detail on how the daily QA would occasionally double in time?
Sure. So we had issues with machine performance check a few times where it wouldn't just fail, it would not record any results. We would run through the whole check and nothing would populate in the results section. And so sometimes it took 2 or 3 times of running it to actually get results to record. So that was one issue. And we also found that without so this was all retrospective, our therapists would occasionally take long breaks that were hard to kind of suss out and figure out when those were happening while they were doing QA, whether it was to help at a different machine or if there was an issue somewhere else. So that was also part of it, but it didn't happen very frequently.
Wonderful. A third question, and it looks like a final question for the moment here, is how is baseline data obtained for the 2 systems, and how easy are they to update or change after a service visit or a calibration?
Sure. So both systems are very easy in terms of setting up baselines. If you're logged in with the correct credentials for machine performance check baselines, you can take your baseline images and then set those as baseline images after the fact. So you could run machine performance check and then set those images. For a SunCHECK machine, you would go and edit your daily and set the baselines in that edit feature. For SunCHECK machine, for especially output measurements, you could do like a monthly check output, and then use the results from your monthly and enter that in once you take your baseline measurements on your daily QA Phantom to set the correct dose. So they're both very easy. They're just slightly different in how they go about it.
Wonderful, thank you. Really appreciate you taking the time today, Dr. Stambaugh, to go ahead and present your data here in the comparison of vendor-dependent versus independent Linac QA. We want to thank everyone once again for joining us. And with that, I think we can go ahead and we can close out the session today. Thank you.